the demo I'm gonna do here is showcasing the very common problem of having a human in the middle of your workflow. Basically, you need input from a human right in the middle of your workflow. The very specific use case that I've uh, built up here is pretending that we've got a longer workflow. And at the very beginning, in order for it to continue, the user needs to confirm their email address. So we have this quote unquote workflow. Hopefully, folks familiar with durable execution will find this architecture I've created very familiar. You've got a workflow here with multiple steps. The very first step is to send an email to the user, and then the entire thing is blocked, waiting until that user confirms their email, clicks a link in their email, right? Which then would hit an API server, and then the rest of the sequence would continue somehow. The problem with this, right? The biggest issue I think that developers face, one of them, is that they just have no idea how long it will take for that user to confirm their email. And so there's a lot of rabbit holes that folks go down architecting systems that can take the first couple steps and then suspend for some indefinite amount of time and then figure out how to pick it back up and continue on after that event has occurred. What I think is really great about Resonate, obviously, a lot, a lot of the modern durable execution platforms, and particularly Resonate, is you can define your entire sequence in a single function and await each step as it goes, right? And so what we're going to do here is we're going to spin this up as, I think a lot of folks will find this similar to probably a worker and sort of a traditional externally orchestrated situation, like using an external orchestrator. And we'll have two services and basically the workflow workers, if you will, running. So we've got an HTTP gateway where we will accept requests. And the first one, we've got a start method that's going to kick off the workflows with an email. The promise ID is workflow-email address. So basically, each invocation will correlate to a very specific ID, right? And then the other route we've got is this confirm. So once the email is confirmed, it will always be confirmed as long as that durable promise persists. And then we have a very simple email service that mimics sending an email. Super simple. Okay, so let's jump into the demo here. I'm going to run the gateway here. Oh, wait, I'm sorry. First, I'm going to run our server. So we're going to run the Resonate server because this is using all remote function invocation. So our server is running. And now our HTTP server is running. Then we're going to run our email service. And then I'll spin up a application node, which some people might recognize as a sort of a worker, if you will. Not required to set it up in this particular architecture, but it is a familiar pattern I think folks are familiar with, this sort of service-oriented layout, where a request will go to the Resonate server first, and then the Resonate server will invoke and resume. And up here, we'll send some, I think I've start. Yeah. Okay, so we'll do test email test1@example.com. This is a user starting the workflow. We can see the workflow started, the email service sent an email, the email was sent. And so now we're at this right here. The workflow is now waiting on confirmation, basically on this to resolve. We need this promise to resolve to unblock the workflow. Resonate makes that just very incredibly straightforward in this very simple example where we can send a confirmation request to the gateway, which then resolves that promise and unblocks the workflow, continuing on to the next steps, however many steps you need. Very cool. I actually did a little dance when this worked for the first time. I'm not lying. It was really cool. So that's great, right? What happens if the workflow goes down? Right, while you're waiting on that confirmation. This is what's really cool is that basically the whole thing's suspended. So let's start another one here. Starts. We can kill it. Then maybe the user confirms. The promise is resolved. We bring the workflow back up. The application node comes back up. And we get the resume message from the server, just like that. Dominic already demonstrated a bit of the distribution aspect of Resonate, but let's do that again here, running another application node with the same workflow code on it. We'll start 1, 2, 3 more. And you can see this picked up user number 3. But again, let's say this one's having problems. Oh, it crashes. And then user confirmations come in. And it just resumes, picks right back off. And you can see it will reprint logs. It's replaying, but it's not doing the computation again. It's not actually sending another email. You can see down here, there's no new email sent. It's not like the function is being re-executed. The results are being pulled from the durable promise during a sort of replay. And we'll completely resume on this other application node. All done. So yeah, I think that's a really common use case we see, right? With humans in the loops and solving for that and being able to just write a sequence in a single function and know that at any point this could suspend indefinitely and be brought back up and resume or recover on a completely different application node even with a human in the loop.